Okay, the techniques of integration, that is chapter number 7. That's we are going to start it again. So there are certain formulas that as sin as cos x square x cos x, like these are the formulas that we will be using to integrate any function. So there are basically three rules, three methods to integrate any function. First is by using integration by parts, second is by substitution method, and third is by trigonometric substitution or integration. Trigonometric integration involves the integration of sine, cos, trigonometric functions. And integration, we are going to start with the integration by parts, that is section 7.1. And this is the formula for integration by parts. If we have two functions, f of x and the derivative of that and the function g dash of x dx, so their integration will be f of x g of x minus integration of g of x f dash of x dx. This is the formula. So in our target or our aim is, in whatever function is given to us, we have to identify what is f of x and what is g dash of x, and then we just have to differentiate and integrate the function and we have to put all those values or all those answers into this function, further simplify it. Or
okay,
this formula and this formula is same. They have just written the formula 1 into a very simpler form, which is shown into the formula number 2. Both are the same. But this one is easy to remember. Okay, so we are going to start with question number 1. Question number 1 is find integral. This symbol is for integration. X sin x dx. Now we have two functions, x and sin x dx is another function. We have to decide which one should be x, or which one should be f of x and which one should be g dash of x. So let me write down the question here.
Which one is f of x and which one is g dash of x?
Let me just write down the question.
Okay.
Is my screen shared with you? I mean,
yes, I can see you writing.
Okay. Example number 1 is integration of x sin x d of x. Let's take f of x as x and g dash of x as sin x. Sin x dx.
Okay, so first we start by figuring out which one's which.
Can you please repeat your question?
So like, what's the first step with integration?
Yeah, the first step, if you are using the method integration by parts, then our first step is to identify what is f of x and what is g dash of x. If we have identified it, the formula for integration by parts is f of x g dash of x dx is equals to f of x g of x minus integral of g of x f dash of x dx. That's the formula.
Okay.
Now we need f of x, g of x. We know f of x is x. We don't know g of x. We only know that.
Why did we choose f of x to be x?
Yeah, because if we differentiate the f of x, that is x, we will be getting 1. If you differentiate the sine
Okay.
x, we will be getting cos x. If you differentiate again, we will be getting sine minus sine x. So this is a repetitive function. This is the function sine x is never gonna be end. If we differentiate x, it becomes 1. So it is reducible. If you differentiate
So
sine
the
x, it's gonna be cos gonna be sine again, sine gonna be cos again. So it is repetitive function. We have to choose f of x, a function that is gonna be reducible. If we
so the
differentiate
easiest
it,
one.
yeah, the easiest one. More than the
Okay.
easiest one, you have to select the function that is reducible. If you differentiate it, like if you have x square, if you differentiate, it's gonna be 2x. If you differentiate again, then it's gonna be 2 only. This function is reducible from power 2 to power 1 and then the constant. But if you look at the sine function, it's gonna be it's not reducible if you differentiate it. Is my point clear to you?
Yes.
Okay. So okay, what we have f of x, we don't have g of x. We have to find out actually g of x from g dash of x, and we don't have any knowledge about f dash of x. So we can easily find out f dash of x if we differentiate it. Right? This is where we need a function that is reducible. We can't select sine as f of x and then we differentiate, it's gonna be cos x, and then we differentiate again, it's gonna be minus x. We need a function that is reducible here. Is my point clear?
Yeah, until now, yes.
Okay. So, and to get g of x, we have to integrate it. Integration and differentiation are like opposite of each other.
Okay.
Okay. So if
So f of x, we write f of x is equals x, and then f prime x equals 1. Okay, so we write both types, like, okay.
Yeah, in this case, we just differentiated it. When we differentiate f of x, it becomes f dash of x, and the derivative of x is 1. Now we need g of x, not g dash of x in our formula. So we have to make g of x by integrating it. So when you integrate g dash of x, it becomes g of x.
Yes.
Right? And now we have to see from our table that what is the integral of sine x. For that, we have to
Sine
go
x
back.
is cosine, right?
Yes, for sine x, it's cosine x.
Okay.
For sine x, it's minus cos x dx.
Okay.
Okay. Okay, now let's put all these value into the formula. So f of x g dash of x is x sine x dx, which is equals to f of x, which is x, and then we have g of x, which is minus cos x dx, and then minus integral of g of x, which is minus cos x, and then we have f dash of x, which is 1. Is it clear?
Yes.
We have dx of this function.
Yeah.
And then we have integral of x sine x dx equals to minus.
Why again? Okay, so the first step is after we get the derivative and the antiderivative, we'll put them in the equation as we did. Yeah?
Yes.
Okay,
Yes.
and then what do we do?
Okay, 1 minute. Let me just correct it out here.
Okay.
The integral of sine x is just cos x, I mean the minus cos x. And when we differentiate this function, let me just write it like this way. F of x is our d over dx is equals to x. When you integrate it, I mean when you differentiate it, it becomes 1. f dash of x. So df is equals to dx. So instead of writing 1, I can write dx. Which I have written here.
Okay.
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 And there is only minus cos x, not dx. Because g of x is only minus cos x, not dx. So it becomes x cos x, and minus minus becomes plus, and then integral of cos x only dx. Is it clear?
Yes. Okay.
Okay.
But what you do? What you changed something? What did you change?
I changed here dx. I wrote here by mistake dx. Then
Yeah.
the integral of g of the g of x is minus cos x only. What I wrote here, g of x is equals to minus cos x dx. So I made a mistake here. I just erased it.
Okay.
Okay, dx comes with when we differentiate the function. So when I differentiate the f of x, it comes dx. So which I wrote here.
Okay.
Is it clear?
Yes.
Okay. Now we have to again take the integral of cos x dx, and the integral of cos x is sin x plus c.
Y plus C.
Whenever you integrate any function, there is always a constant of integral with that.
So we always put plus C.
Yes.
Okay.
That is integral constant. A minus x cos x plus sin x plus c. Did you have any question regarding this example number 1?
Okay. Can you can you just go back and then explain every step, like after we finish the equation, like after you put in the equation, like one by one, how did you do it?
Okay. The question was that we have to take the integral of x sin x dx. Okay. Now we know that we have two functions. One is x and another function is sin x dx. Okay. So our first step is to identify what is our f of x and what is our g of x. So we have to take our f of x, a function that is reducible when we differentiate it. We don't need something that is irreducible, like the function ex. It's never reducible. Whenever we differentiate it, it's gonna give us ex. Whenever it's irreducible function. So this function can never be f of x.
This part I understand. The next part I'm talking about, like the one we put in the equation.
You mean from this part?
Yeah.
Okay. So we just use this formula and we substitute our whatever we got into this equation. So our f of x was x. Our g of x was minus cos x, and then minus of the formula, minus sign, and the integral of g of x was minus cos x, and then f dash of x, which was this dx. Do you have any questions so far?
No.
Okay. And then I just multiplied, minus comes out, x cos x, minus minus becomes plus, and then we took the
so these two you multiply them by each other.
Yes, these two has to be multiplied. Yes.
And then the next part also multiplied?
Yes, the next part is multiplied also.
Okay, and then
minus minus becomes plus, and the integral of cos x dx, and we know that what is the integral of cos x, which is sin x plus constant of integral. So this is the answer.
C.
Is it? Yeah, is it clear now?
Minus. Yeah, now it's clear.
Okay.
Okay, just one. I'll be back. Okay, just like 20 seconds. Okay, I'll just get some tissues.
Okay. Hello. Yes.
Yeah, sorry. Continue. Okay, go ahead.
Yeah, sure. And then now we are going to move further towards the example number 2.
This is a different type of integration or the same type?
The same topic, integration by parts. We are going to do
Okay.
another example on it. So the question is that evaluates ln x dx.
Okay.
Example number 2. Integral of ln x dx. Here we don't have any two functions, like ln x is one function and dx is one function. Like in this question, we had a choice that x is one function and sin x dx another function. There was sin x.
Okay.
Now we have given that ln x dx. So let's take u as ln x and not u, f of x.
And then f of x is ln x.
Yeah, f of x is ln x and g dash of x
is dx. Okay.
is dx. G dash of x is d of x.
Okay.
Okay. Because we don't have any other choice. Like if we can't take f of x as g of x and then g dash of x as ln x.
Okay. Here it doesn't matter, right? Even if we do the opposite, right? Like
No, we can't take. Okay, we can't take opposite. We can't take f of x as dx and g dash of x as ln x. When you differentiate, see, when you differentiate it, it becomes d square x. It is increasing in power. You need something here that is decreasing in power.
Okay, so ln x will become what?
G dash of x.
No, ln x.
Oh, okay. So here you have to integrate. So here you have to integrate it. G dash of x will become g of x, and we have to see what is the integral of ln x.
Okay.
The direct integral of ln x is not possible here. Is not listed in this table.
Okay.
Okay.
So it's better to use the other one.
Yeah, we have to go like the simpler method is that we have to go other way.
Okay, this diagram, what is this table? Will it be given in the exams or we have to memorize?
Sorry.
The earlier table, do we have to memorize it or will it be given in the exam?
Like the simpler function that you have to memorize, but I think it will be given in the exam because in
Okay.
yeah. But when you
And
practice
also I
it,
have a
Mhm.
yeah, I have a quiz tomorrow also for calculus.
Oh, okay. Okay, let's discuss it after, like on the WhatsApp.
Okay.
Okay. So this is our f of x and this is our g dash of x. Now we need f dash of x. So what is the integral of ln x? 1 over x
Okay. All right.
dx. And we have to take the integral of it. G dash of x becomes g of x. And if you integrate the differential function, it becomes x.
Okay.
And then we have to just put all values into this formula, which is f of x, g of x. F of x is ln x and g of x is x minus integral of g of x f dash of x. G of x is x and f dash of x is 1 over x dx.
Okay.
And
So now
that's
we
the
multiply the first part.
yes. And when you multiply the first part, it becomes x ln
ln x
x.
square.
No,
Okay.
it won't become ln inside x is with the ln. We have to multiply the x
Okay.
with the
Okay.
whole. So it becomes x ln
Okay.
x minus this x will be cancelled out.
Okay.
And what you left inside is only dx. Is it clear?
Yeah.
Okay, now you have left x ln x. Okay, what is the integral of dx? It's again
dx is x
x, and there is a constant of integration which is c.
plus c.
Yeah.
So it
that's
becomes
the answer.
ln x plus c. Why don't we minus x from x?
Why don't?
Why don't we take the x ln x, we minus x from it, so it becomes ln x only.
Minus sign is with the integral dx. Okay, so when we integrate the dx, it becomes x. So there is a minus sign comes with x, and then
Okay.
c is a constant. So it can be any value, minus, plus, fraction, any value. So we just
No.
Yes.
No, I'm talking about okay, the last one, it says the last line, it says x ln x minus x plus c, right?
Yes, x ln x minus x
Okay.
plus c.
Yeah, okay. So the first x before the ln x, why don't we do this one minus x, the one after the ln x?
You mean?
So the answer becomes only an ln x plus c.
No, this x is multiplied with ln x.
So it becomes 1, like altogether.
No.
Okay, this is the answer, the final answer, right?
Yes, this is the final answer. This x is this x is divided with x, so only left with dx only. We haven't used any identity or something like that.
Okay.
Okay. Okay, let's go through the example number 3. example number 3 is integral of t square e raised to the power t dt. Okay, so now again we have two functions. One is t square and one is e raised to the power t dt. So now we have to think that which one should be g of x, now g of t, and f dash, wait, it's f of t and g dash of t. F of t and g dash of t equals to. Okay.
Okay, two square. If we derive, it will become 2t,
Yes.
right?
Yes.
So it's going to be easy. So we can use as ft.
We can use f of t as t square, right? That's what you're saying?
Yeah.
Okay.
Yeah,
and
yeah,
then, okay, and then g dash of t becomes e raised to the power t dt. Okay. So
yeah.
we need f dash of t in our formula. So it becomes 2t dt. And we have to
Yes.
integrate it. It becomes g of t. Okay. And the integral of e raised to the
It will be the
power.
same.
Yeah, it will be the same.
Ah, okay. If it's the same, shouldn't we put it in the first because it's easier, or does it matter? Like
Okay,
we
you are.
should put it as f of t.
Okay.
It's
Then
yeah.
it's
Go ahead.
gonna be the same. F of t is gonna be the same. It's never gonna end.
Okay, okay. So it's better to use t
It's
square.
better to
Okay.
use something that is irreducible. I mean, that is reducible as f of t, and we have to further simplify or further think that how can we reduce g of t.
Okay.
Okay, now f of integral of t square e t dt will be f of t, which is t square, and g of t, which is e raised to the power t, right? And then minus sign, integral, and the formula is g of t f dash of t. G of t is e raised to the power t, and f dash of t is 2t dt. Is it clear?
Second. Yeah, clear.
Okay. And then t square e raised to the power t dt, which is equals to t square et, and we have to again take the integral of it, which is, can we take 2 common, which is, I mean 2 outside the integral because that is constant. So it becomes t et dt. We have taken 2 outside the integral, and then is left, what is left inside is t e raised to the power t dt.
Okay, but why do we take 2 out?
Because that is a constant.
Okay, so constant we can take out. Okay.
Yeah, if the constant is multiplied or divided, you can't take the constant out when it's added or subtracted. But when it's multiplied or divided, you can take the constant out.
Okay.
Okay. So integral of t square et dt will be, now again we have two functions, t and et dt. We have to again apply integration by parts.
Okay.
Okay. And let me just erase it out. F of t will be t because it is reducible function, and g dash of t will be e raised to the power dt. f dash of t
Again,
will
again.
be
Can you repeat?
okay. Yeah, we have taken f of t as t, and we have taken g dash of t as et dt.
Yeah.
When we differentiate f of t, we will be getting 1 dt. For that, we have to again take the
Okay.
integral, and g dash of t will become g of t equals to e t dt. Is it clear?
Until now, yes.
Okay. And it's not gt. I mean, it's not dt. The integral of et is only et. So again, applying the integral by part formula, f of t is t, and g of t is et minus integral of g of t, which is et, and et and g dash of t, I think. F
Why are we
dash
doing
of
it again?
F dash of t. Is it clear so far?
Yeah, but why are we doing this part like 2 times?
Because we have the integral formula. In the integral formula, we have again an integration. So if whenever the function has two functions inside the function of the integration, we have to apply the integral by parts. Like in the example number one, when we applied the integration by part formula for the first time, we got this. And then we took the integral of cos x, which becomes sin x. So we took the integration, so we applied the integration techniques twice. Once by using integration by parts method, and then we used again formula, which was for the cos x. Is it clear?
Okay. Yeah.
In
Clear.
example number 2 again, we applied the integration by parts formula till now, and then we apply the integration rule or formula here, and took the integral of dx, which becomes minus x plus c. So we applied the integration twice. In example number 3, when we applied the integration by parts once, we got this. And then we realized that there is again 2 functions. We just can't use any formula that can simplify our t, et, and dt. We have again 2 functions. We have to apply the integration by parts twice now. Is it clear?
Yes.
Okay. So when you apply the integration by parts twice, it becomes f of t was t, g of t was et minus integral of g of t, which is et, and f dash of t, which is 1 dt. So I just wrote dt. And now we are going to apply the integration thrice. Now we have only one function, et dt. So we know what is the integral of et.
Et.
Okay.
So here we do it 3 times?
Yes, here we did the integration, applied the integration techniques thrice. Okay. Now we just need to simplify it. So it is t square et dt equals to t square et minus 2t et minus becomes plus 2 integral of et dt.
Okay.
Okay. And the integral of t square et dt is t square et minus 2t et plus the integral of et is only et plus constant sign of integration. That's the answer.
Okay.
Okay. Did you have any question?
No, not no.
Okay. Okay, let's do example number 4. which is evaluate integral of ex sin x dx. Here again, we have two functions. One is ex, another one is sin x dx. One thing that we can note down here that both functions are irreducible, because when we differentiate ex, we again get ex, again get ex, again get ex. When we get differentiate sin x, we are going to get cos x, sin x, cos x, sin x. This chain is gonna continue. Okay. Now we have to choose let's take u as, I mean f of x as ex and g dash of x as sin x dx. We will be doing both ways, like once trying for f of x as e of x, and the second time we'll be trying f of x as sin x dx.
Why?
Because both functions are irreducible. So okay, let's check that. If we check, if we take e of x as f of x, or if we take sin x dx, what difference does it make? Because there in the previous examples, we know that why we should t square as f of t, or ln x as f of t, or why we should x as f of x. In the previous examples, we had a knowledge that why we should f of x, which one we should choose f of t or f of x. But in example number 4, both functions are irreducible. So let's take f of x as e of x and g dash of x as sin x dx. So f dash of x becomes e of x dx,
Cosine
and
x
g,
other one.
okay, and sin x will become cosine x. Want it to be minus cosine x?
Fine.
The derivative of an integral of sin x is cosine x, minus cosine x.
Oh, okay.
Okay. So we now just have to put it into the equation ex sin x dx, which is equals to f of x is ex, and then we have g of x, which is minus cosine x minus sign of the formula integral of f dash of x, I mean integral of g of x, which is minus cos x, and then f dash of x, which is ex dx. So far we have just substituted our functions into the formula, and then we have ex sin x dx equals to minus ex cosine x, minus minus becomes plus, and then we have ex cosine x dx. Ex sin x dx is equals to minus ex cosine x plus, okay, again we have two functions. ex and cosine x. Let's take u as f of x as ex and g dash of x as cosine x dx. So f dash of x becomes ex dx, and integral of g dash of x becomes g of x equals to sine x. Is it clear?
Yes.
Okay. So f of x is ex gx minus integral of g of x, which is sine x, and f dash of x, which is ex dx. Ex sine x minus integral of ex sine x dx. You realize one thing, that we have got the question again.
The same thing.
Yeah. If we again gonna differentiate it, we are going to get the same thing with the question. Did you get my point?
Yeah.
Okay. For that, we have to take this thing to the left hand side, I mean to the right hand side of the equation. So it becomes ex sine x dx. If it's minus here, it becomes plus here. And then equals to minus ex cos x plus ex sine x.
Okay.
And then we have, this becomes 2 integral of ex sine x dx equals to minus ex cos x plus ex sine x. We just need the integral of ex sine x, so we don't need 2 with it. Dividing both sides of the equation by 2, it becomes ex sine x dx equals to minus 1 over 2 e raised to the power x cos x plus 1 over 2 e raised to the power x sine x. And we have to write down a constant of integration, which is c. We can further simplify it. Yes.
Okay. No, go ahead.
Okay, we can further simplify it by taking half as common. So inside half ex common. So inside is left minus cos x plus sine x plus c. That's the answer. Is it clear?
We cannot further simplify this, right?
No, we can't further simplify it. In this question, we apply the integration by parts formula like thrice, and then we got the question again, and then we just shifted it to the right hand side of the equation, and we just simplified it. Okay.
So we don't have to do the other. You said we have to switch first we do this, and then we have to do another again. What we have to switch them? Do you have to do that?
You mean we can take f of x as sine x dx?
Yeah, you said at the beginning that we'll do this 2 times.
Yeah, let's do it. Let's do the same question by taking f of x.
These notes, the one you're writing right now, can you send it to me like on a as a file instead of having to see the video?
Let me just check it out that I can make it
Like
as
PDF or something?
let me check it out that if I can make the PDF of it and then can send you. If can, then I will be sending you right after the session.
Okay.
Okay, now let's take
Okay.
f of x
Okay.
as
F of
sin
x
x,
as sin x dx.
f of x as sin x, and g dash of x as ex dx. Because I don't want dx with sin x dx. When I differentiate it, it becomes something very, confusing function. So when I integrate that, dx is gonna be cancelled out. So f of x is sin x, and g dash of x is ex dx. So f dash of x becomes cos x, and g dash of x, upon integrating, it becomes gx, and the integral of ex is ex itself. Is it clear?
Mm-hmm.
Okay. So
Yeah, sin x is not minus cosine x.
we are differentiating it, not integrating.
Okay.
The differential of sin x is cosine x. The integral of sin x is minus cosine x.
Okay.
So
Okay.
ex sin x dx. So it becomes sin x ex, because f of x g of x minus integral of g of x and f dash of x, which is cos x dx. Is it clear? Okay, again, we have two functions, ex and cosine x dx. Let's take f of x as ex, f of x as cosine x, and g dash of x as ex dx. F of x becomes f dash of x, and cosine x becomes minus sin x. Is it clear?
Yeah.
Okay. And upon taking the integral of g dash of x, it becomes g of x equals to ex. So f of x is cosine x, cosine x, and g of x is ex. F of x is cosine x, and g of x is ex minus integral of g of x, which is ex, and f dash of x, which is minus sin x dx. Is it clear so far?
Yeah.
Okay, so ex sin x dx. So it becomes sin x ex minus ex cosine x minus minus becomes plus. This minus and this minus becomes plus, and integral of ex sin x dx. Okay, so again we have got the same function. Taking it that side of the equation, it becomes 2 integral of ex sin x dx, and here we have sin x e raised to the power x minus ex cosine x. Dividing both sides of the equation by 2, it becomes integral of ex sin x dx equals to half sin x ex minus half ex cosine x and plus integral constant. Okay, let me just check if we have got the same answer for both. Half ex minus cos x, half ex, I mean the minus is out, cos x plus c, and half ex sin x, half ex sin x plus integral constant. Is it clear?
Yes.
Okay, so whenever we have two repetitive functions, then we can choose whichever function as f of x and whichever function as g dash of x. It doesn't matter that we should take e of x as f of x or sin x as f of x. Both ways we are going to get the same answer. But when we have some functions, like one function is reducible and other is not reducible, then we have to take f of x or f of t as a function which is reducible. G dash of t doesn't matter, whichever function is it.
Okay.
Do you have any question regarding this?
Right now, no.
Okay. Okay. Let's end it here. I think it has been 1 hour.
Yeah. Where's the book? I was trying to do questions the other day. I was answering, but I don't know if my answers are right or wrong because the book doesn't have answers in the back. So what can I do about that?
Which question
Like
you
when
were
I'm
doing?
practicing, I don't know if what I'm doing is right or no.
Your voice is cut.